Hey James.
What's up, Laura? How's it going?
Good. So I was going over the fundamental theorem of calculus, and I got stuck on the first part. I don't really understand it.
Oh, well, that's all right. I can explain it to you, but I was a little confused on actually the second part of the fundamental theorem of calculus. Would you mind explaining that to me?
Sure, that's the only part I actually understand.
Awesome. Well, why don't we draw it out on this whiteboard here?
All right, let's do it.
All right, so Laura, with the first part of the fundamental theorem of calculus, let's start by drawing out a function, f of t. So f of t is this curvy function here, and it is continuous on the closed interval from a to b. Now we've drawn in a point x here that's within the closed interval a to b. So now say we want to find the area under the function of f of t between a to x. Now this can be written out as the integral from a to x of f of t dt. And this area gathering function can be we can write out as a new function, g of x. Now part 1 of the fundamental theorem of calculus tells us that the derivative of this area gathering function g of x is simply f of x.
Perfect. Now, part 2 of the fundamental theorem of calculus is also known as the evaluation theorem. This part involves the actual computation of the definite integral using integration. So basically, the integral from a to b of f of x dx is equal to the antiderivative of f at b minus the antiderivative of f at a. The fundamental theorem of calculus is so important because it establishes a connection between differential and integral calculus. It gives the inverse relationship between the derivative and the integral. And that's the fundamental theorem of calculus.
Thanks so much, Laura.
No problem.